Hello, everyone. My name is Osmanova Aysel. So today I will present my project titled "The Impact of AI Adoption Level on Job Salaries and Growth." So this project analyzes job listings containing details such as role, sector, company size, location, firm size, geographic area, level of AI integration, risk of automation, and necessary competencies, pay, flexibility for remote work, and projected employment growth. So by using the Python, we conduct exploratory data analysis to investigate pay patterns and their connections to AI integration, remote work policies, and position type. So my research questions, I have two main SAMs. So first, salary related questions. How do salaries vary across job titles? Are AI intensive jobs associated with higher salaries? The second one is the future of work questions. Which jobs are connected to have growth versus decline? So, and in all analysis was performed in Python using pandas for data manipulation, matplotlib for visualization, and scikit-learning for building regression and classification models. So my data set, as I said before, publicly available from Kaggle, titled AI-powered job market insights, and this data set is widely used for educational and research purpose in data science and machine learning. So it includes job listings from various industries, automation risk, required skills, salary in USD, remote friendly status, and growth projection. So as I said, this is the columns that my data set has. Next one is the job titles. So as is shown above, the data set contains a variety of job titles, and the most common is role is a data scientist with 554 entries, while the least common is product manager with 186 entries. And this distribution reflects the current demand for data and AI related roles in job market. So here we have the industries. The most common industry is finance, while healthcare is the least common. So this distribution across company size is relatively balanced, with medium companies having the largest proportion. So this is a distribution of salary, shows not perfectly symmetrical, but here we means of salary approximately 111,878 USD, and median is 112,465 USD. So the right tail, higher salaries, is a bit longer. This indicates more high earning roles than low earning ones common in AI and tech fields. So when comparing salaries by job title, the box plot shows the AI product manager and generative AI managers have some highest median salaries among all job titles, and while cybersecurity and analyst and HR manager have the lowest median salaries. This is a salary by AI adoption level. So with the AI adoption level with a medium and high often shows higher median salaries than jobs with low AI adoption. So based on this graph, AI intensive jobs are consistently associated with higher salaries, and in many job titles, medium AI adoption shows higher comparable salaries to high AI adoption, while low AI adoption tends to display the lowest or the most variable salaries. Overall, the relationship between AI intensity and salary is mixed rather than strictly positive. So in my I implemented random forest model to predict salaries and conducted hyperparameter tuning. So key findings include that maximum depths had the greatest impact, with deeper trees captured complex patterns, and the best model used 80 trees with maximum depth 25, achieving an R squared of 0.86. AI ML specialist roles like ML Ops, NLP, and computer vision engineers are the strongest salary predictors. 7 of the top 8 most important features are AI focused job titles. So, industry, company size, and location appear lower in importance than specific job titles. So, I also implemented the linear regression. So, my linear regression model I compared two salary prediction models. So the linear regression model achieved an R squared of 0.65, explaining 65% of salary variation with an average error about $40,000. Of course, the random forest model significantly improved performance. R squared increased by 32%, and prediction error decreased by 49%, and relative error dropped from 15.3% to 64%. So, the next one is job growth prediction. And for growth prediction, I used logistic regression model. It achieves 65% of accuracy on the test set with balanced precision and recall for both growth and decline classes. However, this model shows limitation. It has low recall for growth jobs, capturing only about 15% of actual growth roles. So predicting not growth, which suggests that job growth depends on factors beyond those in our dataset, such as economic trends and or external market dynamics. So in conclusion, this project explored how AI adoption relates to job salaries and growth through EDA and modeling. I found that AI intensive roles tend to offer higher salaries and more positive growth projections. The analysis demonstrates that machine learning significantly improves salary prediction over traditional methods, and AI specialization is a primary salary driver in today's job market, and random forest excels at capturing complex nonlinear relationships. So for future work could include using larger data sets and adding features like years of experience, the level of education, maybe job level, and trying gradient boosting models and incorporating cost of living adjustments. Next one is our my project in IPNB. So here my data set, my pre-processing models. Here we don't have missing values, any. So here our graphs. I want to explain this one. So this is a linear regression. So for prediction, salary prediction, I used linear and random forest. So here, as you can see, my target value salary and features other columns, and they are categorical. So here in pre-processing, we convert categorical data into numerical by using one hot encoder, and then we pre-processing data. After it, we applied linear regression model, and I divided data into train and test 70 and 30%. So here you can see the mean absolute error and R squared. The next one is random forest. So as I said before, my features columns, they are categorical, so we need to transfer them to the numerical by using the one hot encoder, and target value salary is numerical. So test size 70 and 30%, and random forest has three values and depth value. So I use it 100 trees, but 10, 20, 30, 40, 50, 60, 70, 80, 90, 10, 100. And depth values, I use it just 5, 10, 15, 20, 25. So here we are using the hyperparameter tuning in order to know which one is the best model, which has the highest R squared. So we are printing the results here, and after it we need to find the best one in order to train final model with best parameters. So here you see the starting random force hyperparameter tuning, and you see here the highest one is and 80 depth value 25 r squared, the best one. So this is our graph, you can see it here too, and best parameter, and find final model performance. Yeah, here our mineral $7,135 and r squared and average salary. So, and most important features, 7 of 8 is job titles, as you see, most important. But automation risk low and adoption level low, they are in top 10. This is a graph. The next one is job cross prediction. So here we use the logistic regression. For growth, we put it the 1 of 0 for others like decline and stable. So growth binary numerical. This is our other columns categorical. So we need to convert them here. So use the logistic regression. Here I divided for 80 and 20% train and test model. So my accuracy 65% and precision recall F1 scores. Here we see the confusion matrix. So this model is good at predicting not growth.